simplify it piece by piece. So what's 2 divided by 4? They both divide by what? Good, they both divide by 2. So 2 divides by 2 and becomes a 4 divides by 2 and becomes a 2. Now notice 2 is on bottom. Do not float it to the top. It's on bottom. It's got to stay there. All right, so this is what we have so far. 1 over 2. Now we have the same base. X to the 3/4 divided by x to the 1/4. When you divide the same base, you subtract your exponents. And you subtract the top from the bottom, right? I need this report to do. You subtract the top from the bottom. So we're going to be doing 3/4 minus 1/4. So if you needed to, you could use your calculator. 3/4 minus 1/4. But this one's easy because we can do it by hand because they have a common denominator. So what's 3 minus 1? 3 minus 1. 2. So 2 out of 4. So we'll have x to the 2/4 for right now. And then looking at this next part, we have y to the negative 1/2 divided by y to the what? First. Very good. So we're going to once again be doing the top minus the bottom. So negative 1/2 minus 1. So you'll do it in your calculator just because why not use it to make sure you don't get it wrong. So you'll do negative 1 divided by 2 in parentheses. And then you'll go minus 1. It's going to be a decimal. We don't want decimals. We want fractions. So you hit the math key, enter, enter. You get negative 3/4. So right now we have y to the negative 3/4. 3/2 is what I got. Sorry. 3/2. All right. Now from here, we simplify everything that we can. So looking at this, first of all, 2 over 4. Doesn't that simplify? 1/2. So good. This is x to the 1/2. And then we have a negative exponent right here. So what do? Good. We bring the base along with the exponent down to the bottom. We flip it over a fraction. That's going to be y to the positive 3/2. So it's no longer right there. So our final answer, 1 times anything is just itself. So we'll have x to the 1/2, right? Over 2. 2's on bottom, and then y to the 3/2. This would be our final answer. Any questions on that? Okay. I'm going to make sure to put one of these on the test that we'll be having at the end of this unit. So make sure you can still do this stuff. No questions. We're all good. Okay. All right, so let's just get to it. So last time we learned function operations. I'm going to spend a whole other day on function operations today. Because we're going to build our knowledge, we're going to learn function composition, which is a function operation, and we're just going to continue to practice these operations. Because this is a huge thing, guys. It's a huge thing in the core for us to know. You will see stuff like this on the ACT, I promise, okay? So it's a good thing to spend 2 days on. So we learned notation last time. We can do f plus g of x, and we know we can just split that up and rewrite it as f of x plus g of x. Then we have f minus g of x, which we can just split up and say f of x minus g of x. Now this is the one that you're still missing. You've got to be careful. It's such a shame to miss this one because you're not careful. Remember that we're subtracting all of g of x. So with the subtraction sign, if g of x has more than one term, you've got to make sure to distribute the negative 1 through, right, everybody? So technically, if we wanted to think of it like this, f of x minus f of x, and then minus negative 1 times g of x. So it'd be plus negative 1 times g of x. Anyway, just distribute your negative 1 through. So you have to be careful with subtraction. All right, then we have f of x, f times g of x. We can split it up as f of x times g of x. And then we also had f divided by g of x. We can split it up and do f of x divided by g of x. Then with this one, we know that our denominator, the bottom, so g of x cannot be equal to 0. So we said our bottom equal to 0, we solved. And then we said, okay, we restricted our domain, x cannot equal these values, because otherwise our denominator would be 0. Does everybody remember doing this? Are we all good? Okay. All right, so domain. Remember that we've learned how to restrict the domain. We just look for problems. Where are there problems? So there's 2 types of problems. The first one is having a denominator equal to 0. So in something like this, x plus 2 over x minus 3, we would say, okay, we have a fraction here. So our bottom cannot be equal to 0. So we would set it equal to 0. X minus 3 cannot equal 0. We'd solve for x, so I'd add 3 to both sides of the equation, and I get x cannot equal 3. Look, if we plug in 3, it's going to be 0. That's a problem. So then our answer would be x just cannot equal 3. It can be any other number other than 3. All right. The other problem area is, since we're talking about domain of all real numbers, we have to look for a negative under an even root. Now, we've been dealing with square roots. So you cannot have a negative number under the root, because then we'd have an imaginary solution. So we're going to restrict our domain accordingly. So if we have something like this, 3x plus the square root of x minus 3 plus 5, we look for the problem. The problem is underneath the root, so that must be greater than or equal to 0. It can be 0 under there. The square root of 0 is 0. That's okay. That's part of the real number system. So we would just say x minus 3 has got to be greater than or equal to 0. Otherwise, we'd get into the negatives. And then we solve for x once again, so we add 3 to both sides. So x must be greater than or equal to 3. If we plug in 3, what do we get? 3 minus 3 is 0. 0 is okay. Now, if we do a number greater than 3, that's 4 minus 3, which is 1. That's okay, right? Does everybody see how we're just restricting our domain? Is everybody okay? Do you understand what we did? Look for problems. Okay. All right, let's just do a few examples, and I'm going to let you practice on that other worksheet, the additional worksheet. So it says, given f of x is x squared minus 9, g of x, I cannot figure out where to put this. Little guy, they made me switch computers, so I'm still figuring it out. Okay, so then g of x is negative 2x minus 3. We're asked to find f times g of x and state the domain. So we know f times g of x is just f of x times g of x. So we're going to take f of x, which is x squared minus 9. We're going to times it to g of x, which is negative 2x minus 3. From here, what do we do? Distribute, and we're going to double distribute. So I'm going to focus on x squared. X squared times negative 2x is? Good, negative 2x cubed. Questions on that? X squared times negative 3 is negative 3x squared. Now I'm going to distribute my negative 9 through. Negative 9 times negative 2x. Positive 18x, and then negative 9 times negative 3. Positive 27. Then we would combine like terms. Do we have any like terms here? No like terms, so that's our answer, but now we've got to state the domain. Look, do you see any potential problems? Do we have a fraction? Do we have a root? No, so we can say our domain then is all real numbers. We have no potential problems. Guys, if you were to graph this also, you would see that it's growing from negative infinity to positive infinity. So we know that our domain, our x values, are all real numbers. Questions on that one? Okay. All right, so given the same two functions, this time we're going to do g divided by f of x. Now pay attention, because this one is a little, we got to pay attention to the order. G divided by f. So what we know, this is g of x divided by f of x. So g of x is going to go on top. So we have this divided by this. So we have negative 2x minus 3 divided by x squared minus 9. Is everybody following me? All right, now that's our answer. Almost. Let's find the domain now. Let's find the domain. What's the potential problem? The fraction. What would the problem be? This x squared minus 9 would be the problem, because we can't have a denominator equal to 0. So you're saying that we have to say, okay, so x squared minus 9 cannot be equal to 0. Now let's solve for x and see where it is equal to 0. So we can say we don't want our x values to be these things. So what would I do to solve for x? You would what? Good. The very first thing you have to do on this one is isolate x squared. So you'd add 9 to both sides of the equation. So we have x squared cannot equal positive 9. And then now pull, you do right. What would you do now? Square root both sides of the equation. All right, so x is equal to, what happens when we take the square root? We have to account for the what? Well, if we were simplifying, yes, but this one, we're just finding the square root of 9. What do we have to account for? The what? Good, the plus and minus roots. Good. So the square root of 9 is what? 3. So we have to have plus and minus 3. So guys, x cannot equal plus and minus minus 3. Does everybody understand how I did that? Look, if you plug in 3, 3 squared is 9 minus 9 is 0. What's negative 3 squared? 9. 9 minus 9 is 0. Does everybody see how this would be our answer except for x cannot equal positive 3 or negative 3? Yes. Because when we take square roots, we have to account for the plus and minus root. Even roots, right? Good question. Even roots. So what if we were taking a cube root? Plus and minus root? No. Only even roots. Okay, any questions? Good question. Okay, we're not, well, yeah, we'll go through this one, and then I'm going to, so let's go through these last two, and then I'm going to let you work. So f times g of x again. So we're going to be doing f of x times g of x. The reason I did this one is because we're multiplying roots, and a lot of you were asking me about this last time. So this is f of x times g of x. So we're going to be doing the square root of x plus 2 times by the square root of x plus 3. So let's go through and distribute this through here. Okay. Square root of x times square root of x. Can we multiply what's underneath? Yes, so we're going to have the square root of x squared, right? Square root of x times positive 3. 3 square roots of x. Very good. Positive 2 times square root of x. Positive 2 square roots of x. Positive 2 times positive 3. Plus 6. Then from there we'll simplify everything possible. What happens? We have a square root and a square. What happens? Our root cancels out with our power. So we have x, and then we can combine like terms. 3 square roots of x plus 2 square roots of x is how many square roots of x? Very good. Plus 5 square roots of x. Questions on how I got 5 square roots of x? Okay. And then we still have plus 6. From there, we've combined all like terms. We can't combine any of those, not like terms. Okay, so then from there, with domain, where's our potential problem? Good, the square root. So underneath the root must be greater than or equal to what? 0. Now we've already, x is alone, so we're good. So this would be our final answer. No questions on that one. Okay, last one, it's different, that's why I'm doing it, and then I'm going to let you work for quite a while. Okay? This is different than what you've seen. You have not seen this yet, so you all need to pay attention. So it says, find f plus g of negative 3. F plus g of negative 3. So f of x is equal to 3n minus 2, and g of x is equal to negative 2n squared. So we're going to find f plus g of negative 3. So what this is saying is you're going to take f plus g, and then you're going to plug in negative 3. So let's do f plus g first, and then let's plug in negative 3. Okay, everybody? So f plus g would be adding up f of x and g of x, right? So let's add those up. So we're going to be adding them. So f of x is 3n minus 2 plus g of x, which is negative 2n squared. From there, we're going to combine like terms. That's f of x plus g of x. Is there any like terms here? No. So then I'll put it in standard form. Negative 2n squared plus 3n minus 2. Right? And then we would plug in negative 3, because we want to know f plus g of negative 3, not of n, of negative 3. Or not of n, yeah, of negative 3. So now we'll plug in negative 3 into the function. But I added f plus g first. So now I'm plugging in negative 3 wherever there's an n. So we're going to have negative 2 times negative 3 squared plus 3 times negative 3. We're plugging it in for n. And then minus 2. So then from there we'll calculate it correctly. So negative 2 times, you have to put this in parentheses if you're going to use your calculator. Negative 3 squared is positive 9. So we have negative 2 times positive 9. And then right here, positive 3 times negative 3 is negative 9. And then we have our minus 2. So then combining my terms here. So right here I have negative 18 minus 9 minus 2. So you'll just do it in your calculator. Negative 18 minus 9 minus 2. And you get negative 29. So in this one, our answer is negative 29. We're not going to find the domain on this one. We were finding an exact value. We were plugging in negative 3. Does everybody see how I did that? We're all okay. No questions. I found f plus g, then I plugged in what number I was. Calculated it correctly, not making any sign errors. Okay, awesome. So I'm going to have you practice 1 through 6 on this worksheet for today. Guys, really pay really close attention, okay? Really. Okay, so we're going to be doing function composition now. So we're going to be, the reason it's called function composition is we're going to be composing a new function from the other function. So, when you compose a new function from another function by substituting the first function into the other function for the variable. So this is the notation you're going to be seeing. F, and it's said like this, FOG of x. So FOG of x, it's a little mini circle right up here. Now this is not a multiplication sign. It's an open circle, completely and 100% totally different thing. So FOG of x. Now this is how you'll rewrite it because it's easier to see what you're doing with this. So this is a way I can teach you a little trick to help you rewrite this correctly. So everybody pay close attention. Now everybody, to rewrite this, you picture yourself grabbing the x. Is everybody watching? Grabbing the x, smushing it back in with the g. That's g of x, right everybody? Does everybody see what I just did? Grabbing the x, smushing it back in with the g. That's g of x. Then you smush it in one more time, and that's back into f, and it's going to be like this, f of g of x. So does everybody see how I grab the x, smush it back in with the g? Then I grab it and smush it back in with the f, and that's f of g of x. Does everybody see the little trick? We'll practice that a couple times. Okay, now what we're going to be doing is we're going to be taking x, just like if we had f of 4. If we had f of 4, we plug in 4 in for the variable, right, everybody? So now we're going to be plugging in a g of x wherever there's a variable into the function. Does that make sense? Just like if there was a 4, we substitute in 4, we're going to be substituting in g of x wherever there's a variable in f. Does that make sense? Trickiest one of them all. So let's practice this. Does everybody have this at least written down? FOG of x. You're going to grab your x, smush it back in with the g, smush it back in with the f. That's f of g of x. All right, so here's our first example, guys. First example. So we're given 3 functions. F of x is equal to 3 minus x, g of x is equal to x squared, and h of x is equal to negative 2x squared plus 2. It wants us to find FOG of x. So like I just said, guys, I want to rewrite this so I know which function I'm substituting into the other function. So I grab the x, smush it back in with the g. Everybody watching me. Grab the x, smush it back in with the g. That's g of x, right, everybody? Then I grab that and smush it back in with the f, and that's going to be doing f of g of x. So we know we're substituting in g of x into f wherever there's a variable. So now, this is what I'm going to do. Everybody watch carefully. I'm going to go circle what I'm substituting in. So I'm substituting in g of x. This is g of x, right, everybody? I'm substituting it into function x wherever there's a variable. So I'm going to draw my arrows to my variable. I'm going to be making the substitution right there. Does everybody see that? Is everybody sure? No questions. Okay? So we're going to have 3 minus, instead of x, we're substituting in g of x. So what are we going to have? 3 minus x squared. Does everybody see how instead of 3 minus x, we're substituting in x squared wherever there's an x? So now we have 3 minus x squared. Okay, let's combine like terms. We just did f of g of x. Okay, so now let's combine like terms. Those aren't like terms, but let's put it in standard form. So that would be negative x squared plus 3. So this would be our answer. Now let's state our domain. Any problems? Any problems? No, no fraction, no roots. So domain is all real numbers. Part of our answer as well. Yes. We didn't use it in this one. Yeah, we didn't use it in this one. It's just we're going to be using these three for the next few examples. All right, let's do another one. Okay, this time we're given those same three functions. We're asked to find FOH of x. So let's use our little trick. We grab x, smush it back in with h. So we're going to be doing h of x, grab x, smush it back in with our h, and then smush it back in one more time. We'll be smushing it back into f. So we're substituting in which function? H of x. We're substituting in h of x into x. So I'm going to go circle h of x, and we're substituting it into f wherever there's an x. So I'm going to draw my arrow. I'm substituting it in right there. Does everybody see that? So what we're going to have then is 3 minus, in parentheses, I'm substituting. Anytime I make a substitution, I use parentheses. So instead of an x, we're substituting in h. So that'll be negative 2x squared plus 2. I made the substitution. Then I will simplify this and combine my terms. So we have negative in front. So that's like having a negative 1. So I'm going to distribute that through. Negative 1 times negative 2x squared is positive 2x squared. Negative 1 times positive 2 is negative 2. Then I drop down my 3. Then I combine my terms. 2x squared is no other x squared. 3 minus 2 is positive 1. Now, any questions on that? So our domain in this one is what? All real numbers. Very good. No problems. Very good. All real numbers. Okay. Okay, let's do just a couple more. GLF of x. We grab our x, smush it back in with our f. Grab our x, smush it back in with our f. That's f of x. Smush it back in with our g. Now we're substituting in which function?
X squared, right?
We're substituting in, right? F of x. So I go to f of x. I'm substituting that into which function? G, wherever there's an x. So what we're going to have then is parentheses, right? There's the x. We're substituting it in. 3 minus x what? Squared. Does everybody see how I did that? Now I need to simplify this. We know that we have to rewrite that as 3 minus x times
3 minus x.
3 minus x. And then we double distribute. 3 times 3 is 9. 3 times negative x is negative 3x. Negative x times 3 is negative 3x. Negative x times negative x is positive x what? Squared. And I combine my terms, put it in standard form. So I'm going to put it in standard form as I combine my terms. X squared, no other x squared. Negative 3x minus 3 more x's is negative 6x's, and then that's positive 9. And our domain is what? All real numbers, there's no problems here.
That's easy.
Good. I'm glad you feel that way. Very good. That's awesome. Well, this one is one of the more difficult ones. Last example, then I'm going to let you work the rest of the time, okay? Everybody watch carefully. HOF of negative 2. HOF of negative 2. Just like with x, I'm going to grab my negative 2. Since it's an O, I'm going to smush it back in with my f. That's f of negative 2, right, everybody? And then we're going to grab that we smushed it back in, smush it back in with our h. So we're going to have h of f of negative 2. So with this one, I'm going to actually calculate f of negative 2 first. So I'm going to find f of negative 2. I hope you're all paying attention or you're going to get these ones wrong. So now I'm going to calculate f of negative 2. So that's going to be 3 minus what? Negative 2, right? I'm substituting in negative 2 into f. So that's going to be 3 minus negative 2. Well, inside, okay? So 3 minus negative 2. What happens when you minus the negative?
Positive.
Becomes positive. So 3 plus 2 is 5. Does everybody see how I did that? So I'm going to have h of 5. So now I'm plugging in 5 into h wherever there's a variable. So I'll have negative 2 times 5 squared plus 2. And then you'll calculate that. So we'll have negative 2 times 25 plus 2. And then we'll get negative 50 plus 2, which is negative 48. So my answer in this one's negative 48. Does everybody see how to do it when you have a number? You have to smush it back in, calculate the inside, then calculate that new value. Does that make sense? Okay. Now I just want you to practice. We're not going to do another one. Okay, so you're going to finish both worksheets. You can do the bottom of the first worksheet, and you can finish this one up. Make sure you understand there's a difference between f times g of x and f o g of x. Okay, so while I'm here with you, I would make sure I practice some of those o's. G-O-H of n, so like number 18, number 16 on the new one. I would practice those for sure and have me check them. And then I would make sure I do some on the old worksheet too, 3-2, the bottom half. Those are all function composition, pretty much. Not all of them, but most of them. Have me check them as you go, guys. Take advantage of the time that you have with me.